Morning. Am I audible to you guys? Okay. Okay, so today we will start with the public key crypto system. So all those time we discussed about symmetric key distribution, right? So from now on, all the algorithms we check, like DES, triple DES, AES, Bluefish, and all, those are symmetric key encryption. Okay, so from today onwards we will just start public key and crypto system or encryption and all the algorithms available for public key encryption. Okay, let me just share the screen. Okay, so see, there are very two basic principles of any crypto system. Can you tell me the two names at least? What are the two principles for any crypto system? There were four, but the main there were two. Can you name it? Two principle of any crypto system. Anyone? Answer. Question is, what are two basic principles of any crypto systems? There were four features, remember? And I'm asking just two main features. Key generation. Key generation is just an operation. What are the principle for crypto system? Means why we need crypto system. In, it based on some principles, right? Means why we need crypto system. Yes, encrypt message. We encrypt message for what? There were certain features, remember? Security and integrity. Yes, that is correct too. Security, we can also say confidentiality. Remember yesterday also I discussed about traffic confidentiality. So confidentiality and other one is integrity is correct too. Other one is authenticity. So two basic principle of any crypto system, mainly confidentiality and authenticity. Now, in case of symmetric key crypto system, it has problem in means in terms of both of these two principles. Okay, so in symmetric cryptography, what happens? The problem associated with confidentiality is that we all know, like here, a secret key is used for encryption as well as in decryption. Correct? For symmetric key, what users do? There's just one key, and using the same key, we perform both encryption and decryption. That means what? This key must be shared by both the communicating parties by any means or they must just rely on some third party. Remember yesterday we discussed about key distribution center. Other two parties share keys by physically delivering to each other, or just they involve key distribution center to deliver keys. Remember? So, but the problem is relying on third party, again, same problem. There is a risk of secrecy of the secret key. If you are relying on a third party that they will deliver your key, again that very essence of crypto system is like null and void, right? We are depending on someone else. So that's the problem of symmetric cryptography in terms of confidentiality. Okay. Then again, symmetric key also had an issue with authentication. To become like widespread, there was a need for digital signature that assures all parties that a particular message has been sent from a particular person. So means every time we send something, some messages, the sender needs to sign by means of something. Mainly they use digital signature. So with the help of digital signature also, only they can just validate the authentication of a message received by the other person. Okay, so that's the problem of your normal symmetric cryptography. Two problems in confidentiality and authenticity. The main problem is key needs to share, and for that we need to rely on key distribution center, and in case of authentication we just need to sign some digital signatures and all. Okay, so to avoid these things, so public key crypto system is just successful in achieving both these principles. That means your confidentiality and authenticity. So there are six main essence of any public key encryption. This is just like your normal encryption system also. So what are the six elements? Yeah, one is plain text. You guys already know what is plain text. It's just the readable message which we give as input. Then is your encryption algorithm. With the help of this algorithm, we just convert plain text into ciphertext. We just perform different transformation. Then we have public and private key. The difference is here. I know here written is 5, but I am saying 6. 6 is because we have two keys now. One is public key and one is private key. Okay, but in case of symmetric key, there is just one key, and that key is shared between both parties. So here there will be set of keys among which if one is like used for encryption, the other would be used for decryption. Okay. Next is the ciphertext. It just after encrypting the message with the help of keys, we just find the ciphertext, and decryption is just reverse encryption. With the help of decryption algorithm, we just get plain text from a ciphertext. These things you guys already know. It's similar with like symmetric key encryption. So what are the steps in any public key cryptography? Okay, so each user has to generate two keys, one of which will be used for encryption and other for decryption of the messages. So each user has a pair of keys, and among which one has to be made public by each user and the other has to be kept secret. So remember in the first class, around first class, I mentioned that for the public key cryptography, um, anyone can know the public key. Means, uh, or you can say the key has been used for encryption, but only the receiver will use a secret key to decrypt the message. So if a user has to send a message to a particular receiver, then the sender must encrypt the message using the intended receiver's public key, and then will again send the encrypted message to the receiver. And on the receiving the message, the receiver has to decrypt the message using the private key only. So in public key cryptography, there is no need for key distribution as we have seen like in case of symmetric key cryptography, correct? So as long as this private key is kept secret, no one can interpret the message. So in future also the user can change its private key and publish its like related public key in order to replace the old public key. Okay. So now let's see what are the steps for public key encryption. So here you can see Bob wants to send something to Alice. Okay. So from here you can see Bob has many keys. Okay, these are all public keys and each of the keys are meant for particular type of user. Okay, then using the key which is meant for Alice will be used for the encryption. Then an Alice will decrypt the message with the help of the private key only. Okay, so Bob can maintain many public keys and each of these public key will be meant for different users, and the intended user will only use their own private key to decrypt any message. Okay, so this means what? This means it's just simple encryption, right? Now other part you can just say it also helps in authentication. Why it's authentication? Now Bob is using its private key and converting it into ciphertext, and for decryption again Bob is using public key. Okay, then means Alice will again have different um, public key again meant for different persons. So it's just the reverse order. So Alice will also have some public keys, but it will only use Bob's public key to decipher the message. Okay. So this will guarantee the authentication. So this two process I can just write in one single. How? So this process you can just say is source A. In this process encryption will happen, and this process destination is B, decryption will happen, and there will be key pairs. One will be public key for B and there will be a private key for B. Again there will be a key pair source. Using the private key of A, encryption will be done, and again using the public key of A, decryption will be done in the destination side. So if I want to write a simple algorithm like a simple message thing, I can just write maybe your message, you are just think you are just sending a message M and you want to send it to some person and you are just using a digital signature for example. So your M is your message. So this will be sent to the other person. You will just encrypt it with the private key, okay, of your sender. Suppose this is just a form of signature, okay. The digital signature you can just think about it. So digital signature will consist of a message, then we'll use the private key of the sender, okay. So again this message will first encrypted with the sender's private key, then again will be encrypted using intended receiver's public key. That means what? The final message that will be go to the receiver with the help of public key of the receiver and encrypted message of this, okay. Then for the decryption, how will you this one is your encrypted message, okay. You will just encrypt the whole message with the digital signature of your private key of the sender using the public key of the receiver. Okay, for the decryption, what you will do, it will be just opposite. You are going to decrypt the message. You will get the original message by decrypting it by public key of sender, then again decrypt the private key of receiver and your encrypted message. This is for your decryption and this is for your encryption. So this is your ciphertext and this is your deciphered text or normal plain text. Okay. So again, if you want to just generate uh, like any messages from here written xyz and again xy, z is your just encrypted message. So for this figure, you can also write like y will be, this y will be encryption of public key of B, sender B, and X is your message source. Okay, and in the other side, X is just decryption of private key of B and Y. So finally, Z you can say, what is this Z? Public key of B, encryption, private key of A and X. Okay. And again, when you decrypt it, when you need to get the ciphertext, the final will be, you can just represent it as PUA, private key of B and Z. This is nothing but, this is the general form and this equation is only related to this particular image and this is just general form. And these are equations are nothing but this generalized equation. Okay. So next, let's see what's the difference between conventional or your symmetric key versus your public key encryption. Okay. Some question, how there will be two key in symmetric? No, there is no two keys in symmetric key. In asymmetric only there will be two keys. In public key cryptography there will be two keys. In symmetric key just one key. Okay. So this is just difference between, or you can say versus between conventional and public key encryption. So here same algorithm with the same key is used for encryption, and in here two different keys will be used, one for encryption, one for decryption. Again here the sender and receiver must share the algorithm and the key, and here the sender and receiver must each have one of the match pair of keys. Okay, and for the security, what we need to do, we need to keep the secret, keep all the keys secret. There will be just one key, so we just need to keep that particular key secret. But in this case, one of the two keys must be secret, means public key can be known to everyone but the private key should be secret. So out of two, one will be secret, since in conventional method just one key is involved, so that key we need to keep secret. Again, it must be impossible or at least impractical to decipher a message if no other information is available. Okay, and in case of public key, it must be impossible or at least impractical to decipher a message if no other information is available. It's kind of same actually. Here, knowledge of the algorithm plus samples of the ciphertext must be insufficient to determine the key, and here knowledge of algorithm plus one of the key plus samples of ciphertext must be insufficient to determine the other key. So you can say public key encryption is somehow a bit more secure than your conventional encryption. Okay, so what are the requirements for your crypto system? So the computation of the pair of keys, that is private key and public key, should be easy. Okay, so knowing the encryption algorithm and public key of the internet receiver, computation of ciphertext should be easy too. And again, for a receiver of the message, it should be computationally easy to decrypt the obtained ciphertext using his public key. Again, it also required that any opponent in the network knowing the public key should be unable to determine its corresponding private key. Okay, and having the ciphertext and the public key, an opponent should be unable to determine the original key. And the two keys in public and private key can be implemented in both order. Okay, this equation we have already seen earlier. So these are the main requirements. Anyways, the main thing is the key generation should be easier in both case of sender and the receiver side, and generation of public and private key. Now what are the applications of your public key uh, crypto systems? So one is very simple one. So main purpose is just encryption and decryption. You send any message like securely, we just perform an encryption decryption. This is the like basic application. The second one is digital signature. So like if like uh, any purpose, like we need to authenticate a message, we can just use digital signature, right? Or we it can be just encrypted sender private key. So as only the sender can have its private key, it assures that all that messages is sent by particular person. I guess digital signature part, ma'am has already explained. Can you tell me how digital signature works? Anyone? How digital signature works? What is digital signature? It's already explained. How does it work? I guess ma'am already explained. So you need to explain to me now. Tell me. What is digital signature? That's what sir. Oh, তেতিয়া ক্লাছটো ল'ব নাপালো চিস্কই অন নহ'ল এতিয়া লৈ আছে It is an authentication process to confirm receiver. Yes, that's correct. Means what is the basic function? Means how it works. How does it work? So yeah, since ma'am already explained, I'm not going to explain this part. But technically, I have already mentioned it how we use it. So anyways, yeah, tell me how does it work? How does it work? Anyone? What happened? Anyone? How digital signature works? Ma'am already explained it, right? So just tell me. Ma'am, I forgot now, but I'll surely look up. Okay. What about others? Divya, Arindam, Dasi, tell me how does it work? Rupam, Gunasa, Aman. Anyone tell me how does it work? Question please. Lower answer maybe. Seven. Seven. Oh, wait, it will work it will oh, it's true মানে এটা পাৰি মই একেবাৰে বেয়া এযোৰ হেডফোন মই ইয়াতে থৈ দিলোঁ কাৰণ মই সদায় পাহৰোঁ গ'লো মই সেইকাৰণে এযোৰ ইয়াতে থৈ দিছোঁ মোৰ আছে এতিয়া 11 মই কফি খাব নেকি আমি খালোঁ এইমাত্ৰ অ'কে মানে অলপ আগতে আৰু start কৰা আৰু। ঠাণ্ডা লাগিছে forgot. Okay. Others, I guess a few minutes ago also I even showed the whole equation for the digital signature. See, I said this is kind of your digital signature. This this one. From this equation, what can you say? From this equation, what can you say about digital signature? Two keys are generated sending message from source to destination. Anything can be like sending message from source to destination. Message is encrypted with a key and sent, receiver decrypt with other key and get the message. Yeah, that's the normal process of any encryption. So digital signature, you can simply just say sender signs the message with a private key. This message M is your message. So you can say sender can just sign a message with its private key. This is sender's private key. And this signing is achieved by the cryptographic algorithms and it will be applied on a message or to a small block of data and that is the function of the message. Okay, yeah, first when receiver will receive it, it will use the key again to get the message. That's the normal one. Next time I'll ask again, you have to tell me the whole process, how we can achieve digital signature. Okay, so anyways, moving on. So second is your third is your key exchange. So key exchange is mainly like two sides like cooperate to exchange a session key. Mainly here we care about like session keys. Okay, two communicating parties exchange a secret key. It can be also a private key for symmetric encryption to secure a particular transaction, and that secret key is valid for short period of time, and that's nothing but your um, session key, because session key is just valid for a small period of time, and this is only during your logical connection. So there are different algorithms available, and these algorithms can just implement all three applications, and some implement just one or two among these applications. So these three are main applications. So there will be some algorithms which will implement like all these applications, and some will implement just one or two of them. So these are some known public key encryption methods or algorithms: RSA, elliptical curve, Diffie-Hellman, DSS. So these algorithms you can see which one implement all three and which one just implement one or two. So RSA you can see RSA and elliptical curve implements all three features or applications. Then Diffie-Hellman is just one, and DSS is just this signature one. So in next class we will discuss about RSA. RSA is most um, known public key encryption method. So anyways, if I came to this public key encryption, I also want to mention about cryptanalysis. What is cryptanalysis? What is cryptanalysis? Anyone? What is cryptanalysis? Cryptanalysis. What is cryptanalysis? This one you have to answer. Study of ciphertext. Yes, that's the simplest one. Elaborate a bit more. Cryptanalysis. I already mentioned about it in first class, I guess. It hides our data from unauthorized. No, that's encryption. To gain the hidden text in a decoded data. Partially true. The main point is what? When I say cryptanalysis attack, what it tries to do? Finding how cryptography work. Not exactly. To breach cryptography, yes, correct. To breach cryptography, just need to add one point. The main point is that without having knowledge or having some knowledge of your keys. But in by default term is that we are just trying to decode a message without having knowledge of any algorithm or keys. Yes, to gain access, just that without knowing anything. So what are the three main types of cryptanalysis in case of public key? So one is brute force attack. Remember what happens in brute force attack? Brute force, that's a cryptanalytic attack. Brute force. What happens in brute force? Very common one. Submit many password. Not submit, word should be trying many passwords. Okay. So you don't know the correct person. It's like a hidden trial method. You will just keep trying all the possible passwords. Okay. So to prevent the brute force attack, the key size must be kept large enough so that it would be impractical for an trying to gain the access. Okay, that's very possible. Yeah, yeah. That's what I just said. It's like a hidden trial method. You'll just keep trying all the possible combinations of password to get access, or in case of here to decode a message or get a piece of message. So in case of public key cryptography, to prevent the brute force attack, the key size we should must keep it as large as possible, not as large as possible. It should be large enough, because if we keep like too large keys, again it will be a problem. It will be too complicated. And remember, the requirement was that it should be easier to encrypt or decrypt. Correct? So key size must be kept large enough so that it would be impractical for an adversary to calculate the encryption and decryption. But yeah, just like key size should not be so large such that it would become impractical to compute the normal or practical encryption decryption. It will be too complicated. Right? So another type of attack in public key cryptography is that adversary would like try to compute private key knowing the public key, because public key is known to all, right? And sometimes the opponent just try to learn about the private key with the known public key. Okay, that's another kind of attack in case of public key encryption. So one more type of attack is the probable message attack. So if an adversary knows that the that like encrypted message from a particular sender is kind of some particular bit of keys like 56-bit keys, then he would just simply encrypt all possible 56-bit keys using the sender's public key, and because the public key is just known to all, right? And that match all the encrypted message with the ciphertext. So this type of attack can be prevented by appending some of the random bits to the original message. Okay, these are the three possible types of cryptanalysis in case of public key. One is brute force attack. Second is, since public key is known to all, so it will try to uh, learn about or compute the private key. And the third attack is your message attack. Means if it knows the length of a particular message, suppose any bit, then it can just try to find out all the possible 56-bit keys from the public key, which is known to all. Okay, so that's all about your principles of public key encryption. So main things are here. There are two separate keys are used here. Then again, public key encryption system achieves like both confidentiality and authenticity. And public key crypto system is based on invertible mathematics. So it has too much of computations. Okay, then large key size will reduce the probability of brute force attack. Then again, uh, all the participants or like the will maintain their own private and public key, right? So these are the main points. So I'll just stop sharing, and next class we will start with RSA. I'll take attendance. Okay, that's all. Thank you. Next class we'll just start RSA. Okay, that's the basic one. Okay, thank you all.